Hello, Mr. Chan here for Algebra 2. We're going to start a new lesson for 2-5, completing the square. Turn your student companion to page 49 and let's get started on completing the square. Here we go. Hannah and Enrique use different methods to solve the equation x squared minus 6x plus 9 equals 16. Hannah looks like starts with moving the 16 to the other side by subtracting 16. She has a quadratic x squared minus 6x minus 7 equals 0, and she went ahead and factored it. That's her technique. Factor, and she decided to go ahead and solve. And when she did that, she got two answers, 7 or -1 for x. Great. Enrique decides to do a different method. Instead of moving the 16 to the other side, he recognized that the quadratic on the left is actually a PST, otherwise known as a perfect square trinomial. That can be factored. This is something you may have seen in Algebra 1. X squared minus 6x plus 9 is a perfect square trinomial, and it factors to x minus 3 times itself. From there, he went ahead and did a square root both sides. When you square root both sides, you do produce a plus or minus. When he got there, he got x minus 3 equals 4 or x minus 3 equals -4 and solved them individually and got the same answer as Hannah. Question. Does Hannah's method work? If her method is valid, explain the reasoning she used. If her method is not valid, explain why not. Well, Hannah did factor and solve, which I mentioned up there. I'll write it again. And it works fine. Enrique did perfect square trinomial. He went ahead and factored it. And then square rooted both sides. Another method. Remember though, when he square rooted, he created a plus or minus. Don't forget that. Both methods work fine. Just different approaches. Can you use either Hannah's or Enrique's method to solve this equation? X squared plus 10x plus 25 equals 3. Well, I'm looking at the x squared plus 10x plus 25. I recognize it as a perfect square trinomial already. So that means I can use Enrique's method. Would Hannah's method work? Hannah would have done by moving the 3 to the other side. Let's try Hannah's method. If I subtract 3 to both sides, I'll get a quadratic x squared plus 10x plus 22. Unfortunately, 22 can't be factored nicely. So there are situations where Hannah's method produces something where it cannot be factored nicely. So in this case, Enrique wins. Well, not really winning, but his method works. Why does Hannah set her two factors equal to 0, while Enrique sets his factors equal to 4 and -4? For it to equal to 0, we're just seeing where it crosses the x-axis, where you set y equal to 0. Enrique is a little bit different. You're seeing where it equals to -4 or +4. All right. Let's move to the next page. Might as well bring this up now. From Algebra 1, there were some special cases where if you took a binomial and squared it, you got a perfect square trinomial. These are the patterns. There is one of them. If you do with a negative, you got this pattern. These are perfect square trinomials. Both of them. Okay? And a great way, and your teacher might have mentioned this, is that you're doubling the square root of the product of the square roots of the endpoints. That's one way of looking at it. There's a process to do something called completing the square. I'll show you that in a minute. All right. Before we do that, let's go ahead and solve by using square roots. It's one of the methods that we use, Enrique specifically. Because right now, in each of these problems, 1A, 1B, both of those are perfect square trinomials. Those are both perfect square trinomials. Let's factor them. Square root of x squared is x. Square root of 36 is 6. If you multiply 1 times 6 and double it, you'll get 12. That's how you recognize it being a perfect square trinomial. The doubling is right here. Doubling, doubling. Okay? The square root of the ends. So it is a perfect square trinomial, and it is a plus plus. I'm going to combine those together. X plus 6 squared equals 81. And I'm going to go ahead and continue by square rooting both sides. This is Enrique's technique. When you square root, you do produce a plus or minus. Square root cancel each other out. X plus 6 equals plus or minus 9. And finally, go ahead and move the 6 to the other side. Be careful here. We now have x equals -6 plus or minus 9, and you will get two answers. X equals -6 plus 9, -6 minus 9 is the other answer. So this becomes 3, and this one right here becomes -15. Yay! That takes care of that. Remember what this is. This is a parabola on the right, equals to 81, a horizontal line. We used that method in a previous section to see where they cross when we graphed it. Where do they cross? When x equals 3 and when x equals -15. All right, letter B is pretty much the same. I recognize that that is a perfect square trinomial. This is x squared minus, so this is going to be minus minus. Square root of 64 is 8. 2 times, meaning double, -8 will give me -16. Therefore, it is a perfect square trinomial. Put the two binomials together, creating a square situation, square root both sides. Whoops. Square root of 9 is 3. Very nice. And we're almost finished. Add 8 to both sides. I now have x equals to 8 plus or minus 3. Solve them individually. X equals 8 plus 3. Or x equals 8 minus 3. And your answers are 11 and 5. Yay! Not bad. So just like the previous section, graphing it, I just want to show you this relationship here. Graphing that parabola for 1a, I just wanted to show you at 3 and negative 15, the parabola will cross somehow. Oh, that's not the greatest parabola. So I want to show you, and 81. That is the other side of the equation, and your two solutions are negative 15 and positive 3. Okay, so I want to show you that relationship that we did with the previous section involving graphing calculators. I didn't answer the habits of mind, I just wanted to show you this particular relationship with the graph. Okay, so I want to show you that. All right, the next problem involves, for number 2, something called completing the square. You should have done this in Algebra 1, but I'm going to remind you of it right now, how to complete the square. Completing the square creates a situation where you move the quadratic from standard form into vertex form, okay? So keep that in mind. Here you see there's something in standard form, and eventually we want to get it into vertex form, okay? How do we do that? Let's go here to the left and give yourself some room up here, completing the square process. All right, we're going to go from a standard equation and put it into vertex form. That's what we're doing. Now they used x minus p squared equals q, but it's essentially the same thing. The vertex form and their form, those are the same thing right there. Okay, just want to let you know, those mean the same thing. Their p is our h and their k, of course, is our q. All right, now step 1. Check to see if a is 1. A must equal to 1 in order for this to work. If it isn't 1, then factor out from ax squared plus bx. You factor a from those two terms. Second step, I want you to take half of the b term and square it. Half of the b term and square it. Poof. That's called completing the square. And when you complete the square, it creates a perfect square trinomial. Before we actually do example 2, let's do the one from the textbook. Here we go. I'm going to walk you through this. You're supposed to have seen this in Algebra 1. The directions are complete the square. All right, here's the problem. X squared plus 4x plus blank. That's A. Next one. X squared minus 6x plus blank. That's B. I think I may have made this up, to be honest with you. C, negative 2x squared plus 16x plus blank. That's a much harder problem. So they want us to complete the square and factor. Forgot to put that instruction down. All right. Step 1, check to see if A is 1. Yep, great. Step 2, take half of B and square it. B is 4, half of it divide by 2, and you square it. When you square it, you produce, let's see, 4 over 2 is 2, 2 squared is 4. Bam. Guess what? This is a perfect square trinomial we just created. And for additional work here, we might as well practice factoring. That's very easy to do. This is just x plus, square root of 4 is 2, and there it is, x plus 2 times x plus 2, or simply x plus 2 squared. All right, that's factored. Let's try B. Step 1, is A 1? Yes, it is, yay. Step 2, take half of B and square it. B is negative 6, half of it's negative 3. Negative 3 squared is 9, positive 9. Okay, we've just created a perfect square trinomial. Now we just have to factor it. Because we have a minus plus situation, that means my binomials are both minuses. Square root of x squared is x. Square root of 9 is 3. And when you shrink those together, x minus 3 times itself is x minus 3 squared. And there's your factor form. Yay. All right, I think we're saving the third one for last. It's the hardest one. Is A1? No. Uh-oh. I need to factor out a negative 2 first from those first two terms. Okay? Negative 2x squared divided by negative 2 is positive x squared. 16x divided by negative 2 is minus 8x. Make sense? We're just applying the distributive property backwards. When you're dividing, we're just going backwards of multiplication. And now that I've taken out a negative 2, I can now work on the inside quadratic. Yay. A is now 1 inside the parentheses. B is negative 8. Take half of that and square it. When you take half of negative 8, you get negative 4. Negative 4 squared is positive 16. Yay. So this is a perfect square trinomial with a negative 2 in front of it. Let's go and factor that. Square root of 16 is 4. It's a minus plus situation, is minus minus. So my final answer is negative 2 times x minus 4 squared. That is your factored form. Yay. Any questions? I hope you remember this from your Algebra 1 days. All right. Let's try number 2. Okay. Number 2 is an equation. Number 2, A, B, C we just did are expressions. There's a difference between the two. We have x squared minus 6x minus 11 equals 0. What I want to do is set aside the negative 11 over here. Just move it over there. Maybe if you want to, we can move it to the other side in a moment, okay? We will. Let's not worry about it right now. All right. Ooh. Is A1? Yes. Take half of B and square it. Now this is an equation now. Things operate a little bit different. When it comes to equations, you have to balance it like a teeter-totter or a seesaw. So when you complete the square, you're actually pulling a number out of the air. Half of negative 6 is negative 3. Negative 3 squared is positive 9, right? Oh no, oh no. I just pulled a plus 9 on the other side, on the left, and it's now unbalanced. I need to add the same amount to the other side to balance the equation. Okay. Ooh. I've created a perfect square trinomial right there, which can be factored. X squared minus 6x plus 9. The 9 in the square root of 9 is 3. It's a minus plus situation, which means this is minus minus. You know what? We're almost to that form right there. X minus p squared equals q. I'm going to go ahead and move the 11 to the other side. That's allowed. That's allowed. Just move it to the other side. On the left side, I can now consolidate x minus 3 together. And on the right side, 9 plus 11, the balance equation is 20. That was just getting us ready to create equations of that form. All right. Woo. That was a lot of work. Now remember, this section involving completing the square is a technique that isn't necessarily what teachers and students will go to first. This is probably the longest way of solving equations. But it does allow you to convert from standard form to vertex form. That's one of the main reasons. All right. 3a and 3b is kind of the same. We just have to solve it. Write a little small. What I'm going to do is move the non-x terms to the other side for number 3a. Okay, here we go. Subtract 8 to both sides. I'm writing a little small. I'm going to zoom in so you can see a little bit better on the video. There we go. All right, much better. Woo. Thank goodness, Mr. Chen. When I do that, I have negative 8 equals x squared plus 4x. Check. Is A1? Yes. Half of 4 squared is next. Okay? And that gets planted right here. Half of 4 is 2. 2 squared is plus 4. Oh no, it's unbalanced. I need to add 4 to the other side as well to balance the equation out. Great. Well, the whole point of that is to create a perfect square trinomial. That perfect square trinomial is now x plus 2 times itself, or simply x plus 2 squared when you factor that. On the other side, 4 and negative 8 are negative 4. Wow. They're actually giving us some crazy problems here, because I can see right now we're going to run into something very different. Because Enrique, remember from the opener, at this point, square rooted both sides. Holy cow. Wow. Do you see the tie-in to imaginary numbers right now? Square root go away. But on the other side, the square root of negative 4 is 2i. This parabola never crosses the x-axis. It floats above it, to be honest with you. Let's go and isolate x, subtract 2 to both sides. And I don't really care, but let's put the real part in front and the imaginary part in the back. And ladies and gentlemen, there's your answer. Negative 2 plus or minus 2i is the answer. This is an imaginary solution. Crazy. This parabola does float above the x-axis. All right, this is why Algebra 2 is complicated. They just had to make it a little more twisty with the imaginary numbers. All right, let's move on to 3b. Same process. I think it's going to have the same outcome. Kind of bored with that sometimes. I wish they'd mix it up a little bit. I'm going to move the 17 to the other side to give myself a little room. Negative 17 equals to x squared minus 8x. Let's check everything, okay? Is A 1? Yep, A is 1. Great. Half of negative 8 squared is next. Half of negative 8 is negative 4. Negative 4 squared is positive 16. Oh no, I just have a balanced equation. Now it's unbalanced by adding 16 to both sides. I'm going to add 16 to both sides to balance it out, right? Like that. This creates a perfect square trinomial, and that perfect square trinomial can be factored. x minus 4 times x minus 4, or simply x minus 4 squared. On the other side, I'm going to get another negative number. Oh no. When you square root a negative number, it does produce an imaginary unit I. Square root goes away. I know, it's the same exact problem. I wish I had something slightly different. Not that exciting right now. Square root of negative 1 is I. And my last step, add 4 to both sides. All right. Final answer, x equals to 4 plus or minus I. Whew. Crazy stuff. All right. Any questions about 3B? Let's move on to 4. I'm sorry, the habits of mind at the bottom. Zoom out a little bit so I can read everything. Richard is completing the square to solve the equation 2x squared plus 8x equals 19. He wrote 2 parentheses x squared plus 4x plus 4 equals 19. What number should Richard write in the blank is the question. So what he did was he factored out from only those 2 right there, a 2. And here's the challenge. When he completed the square, he got a 4. Right there. The crazy thing is, on the other side, if you put a plus 4, the equation will still not be balanced, because technically he did take out a 2 earlier from the first 2 terms. Think about it that way. He took out a 2 from a 2x squared. He took out a 2 from 8x. But that 4 on the inside you're introducing, aren't you introducing 2 of those 4s? So on the right side, you should introduce 2 of those 4s as well, because they're doubling the whole thing. It's like a distributive property, okay? That's the number he should add, and that number is 2 times 4 is 8. That is the number that you should introduce. Next page. I'm going to skip this particular problem, number 4, and jump to number 5. Ooh, write a quadratic equation in vertex form. Okay, so the last few problems we were solving, got an answer for x. Here, we're just rearranging the furniture, completing the square technique, and then putting it into vertex form without having done anything to it. We're just changing the way it looks. We're going from standard form to vertex form. Okay? Just a reminder what that is. Standard form is ax squared plus bx plus c to y equals a times x minus h squared plus k. That's what we're doing. We're going from one form to the other. Please follow along. Let's do number 5a. Ugh, not a great start. You know what? I'll leave 5a second. Let's do 5b. I'll explain in a minute why I'm doing that. 5b is a1. No. I got to factor out from the first 2 terms a 2. So when I take out a 2 from 2x squared plus 12x, I get x squared plus 6x. Hey, give myself some space here. Then we rewrite the plus 9. Nothing's really changed. I just took out a 2 from the first 2 terms. Okay. Woo, here we go. Let's take half of b and square it. Half of 6 is 3. 3 squared is 9. We just introduced, now remember, that 2 is important. We pull out of the air 2 times 9 out of the air. I'm not going to put 2 times 9 on the other side. I'm going to do it on the same side. I'm going to balance it by doing minus 2 of those 9s. Does that make sense? If I did balance on the other side, it would be moved to the right-hand side and it would become a minus sign. This is the balance, the same side. Remember, I just introduced 18. 2 times 9 is 18, right? All right. Let that sink in for a moment. This is the balance part, okay? To balance that out. Let's rewrite this nicely and factor that perfect square trinomial. Psst. There's a 2 now in front, times x plus 3 times x plus 3 when you factor. X plus 3 times itself is x plus 3 squared. And then simply on the end, we have 9 minus 18. 9 minus 18 is minus 9. Ladies and gentlemen, we just pulled that out of the air by balancing, by factoring the 2. We just created the equation in vertex form. Woo, crazy. Some characteristics. Vertex looks like it's at -3, -9. That's your HK. And your A value is positive, which means that it opens up. Just a bunch of little things. Okay? Opens up, blah, blah, blah. All right. That was actually the easier one out of the two. If you look at number 5A, my concern is the odd B value. When you take out a -3 from those terms, you'll get x squared plus 3x. Ouch. Ooh. We need to complete the square there, don't we? Right? Ay, ay, ay. Half of 3 is 3/2. 3/2 squared is 9/4. Holy cow. I need to balance that out because I just pulled that out of the air. 9/4. How many 9/4 did I introduce? I introduced -3 of them, right? I need to balance it out by doing plus 3 times 9/4. Make sense right there? Because that's the opposite of the negative sign. Woo, crazy. Fractions, right? All right. In terms of the perfect square trinomial, all you have to do is square root 9/4. That's the trick. You'll get 3/2 back. Look familiar from your half of PST there. I mean, half of the B value squared. Now, got to clean up this fraction here. 3 times 9/4 is 27/4. Ugh. This is where you break out the ABC button on your calculator. Ooh, I got to multiply top and bottom by 4. That gives me 28 plus 27 is 55. I think I can get away with that. (28, 27, 55/4). Ouch. That is the answer. Crazy. If you really wanted to know the vertex is the opposite of the H. -3/2, comma 55/4 is your vertex. This particular parabola opens down. You know what I forgot to mention? Since it opens down, it has a maximum. The maximum value is 55/4. Over from earlier, this one opens up, this one has a minimum. That minimum, the low value is -9. All right. I don't know about you, but I'm ready for the last page. Woo. This is quite a lengthy lecture here. Here we go. Let's crank out the last page here. Solve by completing the square. This is going to be a lot of work. Hang in there. All right. X squared plus 12x. I'm going to move the 11 to the other side. And now I'm going to complete the square. Half of 12 squared is 36. Oh no, I better add 36 to the other side. Right, 0 minus 11 is negative 11, great. This creates a perfect square trinomial. That's factorable. X plus 6 times x plus 6, or simply x plus 6 squared. Negative 11 plus 36 is, 25? Oh, nice, yay. Next, let's go ahead and use Enrique's technique, square root both sides. And the square root of 25 is 5. Hey, square root is x plus 6 left. Subtract 6 to both sides. And clean that up. 5 minus 6 and negative 5 minus 6 will give me two answers. Negative 1 or negative 11. There they are. Great. Let's do number 6 next. Any questions about number 5? Ooh, number 6, I got to take out a 3, don't I? Yep. Give myself some room there. At least they moved the 27 to the other side. Very cool. When I take out a 3, I'll be left with a x squared plus 4x. And I think I'm ready to complete the square. Half of 4 squared is 4. Oh no, I just pulled that out of the air. How many 4s did I introduce? I introduced 3 of them. So to balance that out, I got to do plus 3 on the opposite side of those 4s. Make sense? That's a perfect square trinomial. X squared plus 4x plus 4 can be factored to x plus 2 times x plus 2, or simply x plus 2 squared. And on the left-hand side, I have 27 plus 12. Looks like 30, wow, 37? That's kind of weird. Wait, 12, 39. Ha 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 ha. Oh, I just realized something. I can't believe I didn't notice it earlier. Did you know that 27, 3, and 12 from the original problem can be reduced? I didn't notice that. Let's reduce it really quick. Yes. That gives me 13, doesn't it? Oh, that would have made our lives a little easier. That's okay. No big deal. All right, let's do Enrique's method, square root both sides. Ooh, 13 cannot be broken down further. You leave it as a radical. But I can move the 2 to the other side. Final answer is an ugly number. The two answers are negative 2 plus root 13 and negative 2 minus root 13. Ooh, wow, are we done yet? Number 7, speaking of, I didn't notice in number 6, we can reduce everything by 2. That would make our lives easier. Let's divide everything by 2. Just to reduce the heck out of it. 0 divided by 2. 2, 6, and negative 14 divided by 2. Yes. Oh no, it creates a fraction. Yikes, 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 yikes. That's okay. Let's give ourselves a little room. Let's move the 7 to the other side. X squared plus 3x. Let's take half of 3 and square it. Ouch. That gives me 9/4. Sounds familiar. I got to balance it with the 9/4 on the other side. That looks very familiar, doesn't it? We create a PST when we complete the square there. That gives me x plus 3/2 squared. Ooh, 7/1 plus 9/4. Multiply top and bottom by 4 right here. Ouch. That's 28 plus 9 is 37. Oh my gosh. This is hurting the brain. Square root both sides. Yikes. And I can't do anything for 37 forces. Leave it alone. And subtract 3 halves of both sides. Running out of room here a little bit. So I just realized something. 37/4 as a fraction can be split up with a radical because the square root of 4 can be doable. Isn't that interesting? So I now have 3 plus or minus 37, whoops, underneath the radical. But the 4, square root of 4 on the bottom is a regular 2. Isn't that interesting? Can I just put them together as a fraction? Yeah. This is allowed right there. Whoops. There's your answer. All right. Whew, this is a long section. Any questions about number 7? Let's move on to number 8, where we're converting it from standard form to vertex form. Wish me luck. Here we go. Give yourself a little space. Bam. Leave the -6 on that side. We're not solving anything. We just want everything on one side of the equation. Half of 6 squared is 36. No, I'm sorry. Half of 6 is 3. 3 squared is 9. Just pulled that out of there, didn't I? I need to balance it on the same side. This is the balance on the same side. Because you're really not wanting to change anything, right? This created a perfect square trinomial, a PST. And that PST can be factored x plus 3 times itself, or simply x plus 3 squared. On the back end, we have -6 minus 9. That gives me -15. And congratulations, there's your vertex form. Some characteristics. A is positive. It opens up. My vertex is at -3, -15, just looking at HK, and -15 as a minimum. Woo, crazy. How about number 9? Oh yeah, the minimum. I just identified, -15. Ha, ha, ha. Number 9 is a little tricky. I'm going to take out a -2 first from the first 2 terms. And then move the -42 on the back end. Just leave it way down there. When you take out a -2, I'll be left with a x squared minus 10x. Yeah? Half of -10 is -5. -5 squared is 25. That's what I did. Oh no! How do I balance this -2 from the outside? I got to balance it by adding 2 times 25, because there's a minus sign right there. Makes sense? Balance it on the same side. This gives me y equals -2 times that PST right there. Psst. That PST is x minus 5 times itself, or x minus 5 squared. And over here, I got 50 minus 42 is 8. Yay! There's my final answer. Y equals -2 times x minus 5 quantity squared plus 8. This particular parabola opens down. A is negative. It does have a vertex at 5, 8. Cool. And that 8 is a maximum because it's opening down. Wow. I think the only thing I want to say with number 10, any questions about number 9, is that it opens downward. It has a maximum. We're not going to worry about that. You can use a graphing calculator. Woo! Wow. Can't believe it. I am finished. Let's go ahead and call it done. Thank you very much, everybody. Talk to you next time. Bye-bye.